All right, welcome back. So now what we're going to do is we're going to solve some applications. Okay, now it's time to apply what we've learned to real word problems. Okay, so here's the first example. So now, in this, and I'm just going to read it. It says, a stone is thrown from a 100-meter cliff at a 30-degree angle from the horizon, right? So 30-degree angle of the horizon, right? So here's the horizon. So we're talking about that angle. Okay. It travels with an initial speed of 20 meters per second. So you can see that time is measured in seconds here. The height of the stone after release is modeled by this function. Now, there's some assumptions that we're making here, just so you know. I mean, one of the assumptions that we're making is we're not really taking the height of the person into account. We're going to assume that's negligible. So whether the person's 4 feet tall or 6 feet tall, because when they release the stone, obviously that's going to have a slight effect. Right, but we're gonna this formula here assumes that there's no we're not counting that. Okay, but anyway, that's beside the point. That's my physics background coming out. So now height is measured in meters, right? You can gather that just looking at the units here, right, of the speed, right? So the height is measured in meters. T is time, which is going to be measured in seconds. That's given, again, we can deduce that from what's given in the problem. Okay? And the time is also measured at, this is the number of seconds after the rock is released. Okay? So that's the amount of time that passes once the rock leaves the hand. Okay, so now here's the questions. It says, at what time will the stone be a maximum height? Well, okay, so we're talking about a parabola, right? So the stone is going to be traveling, right, at a 30-degree angle, initial angle, right? And it's going to be, right, and gravity's going to take over and it's eventually going to come down and it's going to have this parabolic shape. So it's going to have a maximum height, okay? So that means that the maximum height happens at the vertex of this trajectory, right? So now all we need to do is find the y value of the height, right? So what do we do? In this case here, well, okay, they're not asking for the height yet. They're asking for the time. It says, what time will it be at the maximum height? Well, in this case here, we're going to use the vertex formula because we're talking about t, time, which is sort of like our x value, right? So what time does the height, the maximum height occur? Well, that's going to be just using the vertex formula. So in this case, it's going to be t equals what? Negative b over 2a. In this case, b is 10, so it's going to be negative 10 over 2 times negative, right? Because again, the height function is negative 4.9 t squared plus 10t plus 100. So A is negative 4.9. So we're going to put negative 4.9 here. And so what do we get? We get, so negative divided by negative is positive. So this is going to end up being positive, which makes sense because in this case, time is always going to be positive, right? And so far it passes my gut check. And so this is going to be 9.8, right? So it's going to be 10 divided by 9.8. Okay, so in this case here, it's going to be slightly above 1 second, right? So approximately 1 second after release. Let me grab my calculator because I don't know exactly what that is. Okay, 1.02 seconds. Okay, so that's going to be 1.02 seconds. So that's going to be 1.02 seconds after release. All right, cool. Okay, now the next question is, what is the maximum height? What is the maximum height? Now, here's where you have to be careful. Okay? The maximum height, now we're on a 100-meter cliff, right? So we're going to say, hey, what is the maximum height above the ground? Well, in this case here, they want to know the maximum height above ground, meaning that, hey, we also have to take into account that we're 100 meters above the ground on a cliff. Okay? So when we solve this, this is going to give us the maximum height above where we're standing. But then we have to add, oh, hold on a second. No, I'm sorry. This accounts for the height. I'm sorry, I'm looking at it now. So never mind, disregard what I said. This formula gives you the maximum height, or excuse me, gives you the height above ground, okay? I'm not going to explain how I know that, but I just realized looking at it that this function takes into account that you're standing on a 100-meter cliff. So disregard what I just said. So all we have to do in this case is, and I think they said that in the problem. Yeah, the height of the stone above ground is modeled by this. So all we have to do is take the 1.02 seconds, plug it into our function, and then plug it out, plug and chug, and then they want us to round to the nearest meter, okay? So let's do that. So if I do h of 1.02, okay, and so that's going to be negative 4.9 times 1.02 squared plus 10.1.02 plus 100. Okay, so again, if I take my calculator, we're just going to just chug it out. Okay, so it is going to be, now I get 105.102. So if we round that to the nearest meter, we get 105 meters above ground. Okay, so approximately 105 meters in units. 105 meters above ground. All right, cool. Now the next one, the last thing they want us to do is determine when the stone hits the ground. Okay, so when does the stone hit the ground? That's when what? The height is equal to 0, right? So they want to know, hey, at what time, how many seconds after release does the stone hit the ground? So that means the height of the stone when it hits the ground is at 0. So we've got to solve for h of t equal to 0. And so in this case here, because of the formula, we're definitely not going to factor that. That's not going to be factorable, okay? I definitely will use the quadratic formula in this case. So in this case here, we're going to use t equals, what? It's going to be negative b plus or minus the square root of b squared minus 4ac divided by 2a, right? And so our a is negative 4.9, our b is 10, and our c is 100. So let's plug it in. So this is going to be negative 10 plus or minus the square root of what? B squared, which is 10 squared, minus 4 times a, which is negative 4.9, times c, which is 100, all divided by 2 times a, which is negative 4.9. So now what I'm going to do is I'm going to calculate the discriminant first. Okay, let's get that out of the way. Okay, so we get okay, so I got 2060 as the discriminant, so I'm going to take the square root of that. Oops. Okay, so I get approximately 45.387. Okay, so now what I'm going to do is I'm going to take negative plus that because there's a plus minus here. So let's do the plus. So it's going to be let's do negative 10 plus hold on a second. Okay, negative 10 plus our square root, what we got. And then we're going to divide that by negative 9.8. And so we got negative 3.61. So we got t equals negative 3.61 seconds. But we have two answers here. So let's do the second one. So this is going to be so now we're going to do negative 10 minus the 45.387, right, that we got from the square root, and divide that, oops, hold on, we're going to divide that by our negative 9.8. And we got 5.65. So positive 5.65 seconds. Okay, so there are the two answers. So now the thing is when we write down our answers, especially when it comes to word problems, we don't want to write down just all the answers, because remember, you know, in a word problem we deal with physical realities, right? We got to deal with the universe, right? And so there are limitations and restrictions, and we got to remember and keep in mind what possible restrictions there might be. So in this case here, the negative 3.61 seconds makes no sense whatsoever, because that means that the rock hit the ground in the past, right? Approximately 3 seconds, 3.5 seconds before we threw it, right? So that makes absolutely no sense. So we would not count that as a real answer. That would not be one of our answers. So the real answer is 5.65 seconds. Okay? That is the answer. So the rock hit the ground approximately 5.65 seconds after release. All right. I hope that was helpful. Have a great day.